Hello, today I'll be demoing my project, the shader for our ray tracing engine. So first of all, changes that have been made. The main one is that we have added a light class. So it has a position, intensity, a draw method to draw spheres that represent the lights, and our light constructor as well. Then if we go to our CPP file, you can see we have our setup, and in the setup we have a couple lights. I have set up two types of lighting here, a 3-point light, which you can feel free to test, or the key light as well. So I'm gonna use just one light because I like the way that looks, but you can feel free to test the 3 lights as well. Then we have our update method, which just sets general flags, our draw method, in which we draw the light spheres, and then we could go straight up to our ray tracing section. So here we have two new functions, the Lambert shading and the Phong shading sections. So each of these calculates using this equation. I won't get into it because we've already seen this in class, but these are some needle equations to calculate the lighting. Then we can go to a render method. All this is doing is the same as the previous project, looping through the pixels, and then just checking these flag variables to check if we want Lambert or Lambert and no no Lambert or Lambert and Phong shading. My bad. So we check if we have a hit. If we have a hit, we get that point, and then we set some variables here for shadows. Then we loop through the lights. Then we check if a ray generated from that point to the lights is blocked by anything. If it is, we are shadowed, and we set a color to a shadow color and break. So we don't render anything else but that shadow, which is pretty efficient. Then if we are not shadowed, we go ahead and do our Lambert and Phong shading, or no shading if we prefer to do that. Then I have the progressive render method, which is the same as in the previous instance of this entry. Here we look through the pixels and do a little modular check with each sample. So all this does is it starts as a really clear image, and then it becomes, as a grainy image, it becomes clearer and clearer over time. Then we have our ray trace method from the previous one. Yeah, everything is pretty much similar to the previous lab. So why don't we go ahead and run the code. You should be able to see here we have our setup. We have a light, we have our 3 spheres, which are actually sorted by distance. So we just go ahead and render the image with no shading. It looks like so. The light is that way, and we can see the lighting producing shadows in the environment, just like so. And the shadows are connecting. Then we can turn on Lambert shading, and with Lambert shading, it would look something like so. We would have a little bit of a diffuse shading, and then we can go ahead and turn on Phong shading, which is going to add those neat specular highlights, just like so. Now, why don't we go ahead and also test the grid? We can show our XYZ coordinates. We can also show the last view plane where we took a picture from, and we can also save an image if we decide to. Why don't we go ahead and turn on the progressive renderer? So all this does is it renders the image, and it becomes clearer and clearer over time, which is a feature I honestly love. So we can spin around, and you can see the image become clearer and clearer. So this is usually faster than trying an angle and then rotating and then pressing render, trying angle, moving around, then go ahead, now press render. So this is kind of a more intuitive way to do it on the go, if you will, which is super fun. So we can look at different angles, test to see what we like. I want to do improvements. I want to get rid of those little lines that form, those little artifacts that form from the corners. And I also want to see if I can make this a multi-threaded algorithm to make it faster. But yeah, this is my project with all of the lighting calculations ready and set up. Thank you so much for watching.